We're going to finish the section by looking at a couple application problems. So our first application in example 6, we're going to look at a problem involving the Pythagorean theorem. So a reminder about what the Pythagorean theorem says. Pythagorean theorem states that the sum of the squares of the lengths of the legs of a right triangle equals the square of the length of the hypotenuse. Okay, remember hypotenuse is always across from the right angle. Okay, in other words, with a right triangle drawn like this with A, B, and C, A squared plus B squared equals C squared. So since squared values are involved, the Pythagorean theorem will often result in a quadratic equation. So our problem in example 6 is that a wheelchair ramp will have a vertical rise of 122 inches along a 120-inch sidewalk. How long will the actual ramp be? Okay, so let's draw this out. We've got a vertical ramp of 22 inches along a 120-inch sidewalk. Okay, and so we want to figure out how long the ramp will be. That would be this part. So drawing out the situation, we have a right triangle with our right angle right here, and we're asked to know what's this length of our ramp. So using the Pythagorean theorem, we would have 22 squared plus 120 squared equals x squared. If we add on the left-hand side 22 squared plus 120 squared, we get 14,884 equals x squared. So this is just a simple quadratic equation that we can solve with the square root property. Okay, so if x squared equals 14,884, x would equal the square root of 14,884 and negative 14,884. Since x represents a length, we would want to disregard that solution since lengths cannot be negative. And application problems usually ask you to round, so let's go ahead and take the square root. If it's a decimal, we'll round. If it's exact, then we'll just leave it as exact, of course. So square root of 14,884, we get 122 exactly. So 122 inches will be the length of the ramp. Our last example says that a 200 cubic inch box will be made by cutting 2-inch squares from the corners of a sheet of cardboard. Find the length and the width of the sheet of cardboard needed to make the box. So the idea is we take a sheet of cardboard and we cut squares out of the corners like this. Okay, and then I can take what I have remaining and fold that up like this, fold it up like this, and fold this side up and the other side up and make a box. Okay, so what we're going to have, we're going to assume that we have a square, not a rectangle like I have, but we'll have this length be x, this length be x, and we're going to cut 4 inches all the way around. So notice when I do that, this will be 4-inch cut right here. If I fold that up, the height of my box will be 4. And then the length and width of my box, I'm starting with a length of x, and I'm taking 2 and 2 out. And sorry, I think I said 4 before. The height will be 2 when I fold up, since we're making 2-inch cuts. Okay? And length, starting with x, but we're cutting 2 inches out of each corner, so we're going to subtract 4. And same thing, width, x, and we're going to cut 2 inches and 2 inches, so x minus 4. So let's draw a picture of this. Now we've kind of seen a 3-dimension version. Again, the idea is we're taking our square sheet of cardboard, which has lengths of x by x, and we're going to cut 2 inches by 2 inches out of each corner. So if we do that, what we have left, starting length was x. I've cut 2 inches out and another 2 inches out. This will be x minus 4. And same thing here, x minus 4. And when we fold up, this becomes the height 2. So volume for any box is length times width times height. For our situation, it says the volume should be 200. The length is x minus 4. The width is also x minus 4. And the height will be 2. Okay, well, if we rewrite this slightly, bring the 2 out front, since there's two x minus 4's multiplied together, we could call that x minus 4 squared. So this is nothing more than a quadratic equation that we solved with the square root property earlier. So square root property, we'd want to divide by 2, giving 100 equals x minus 4 squared. Take the square root of 100, and we'll have square root of 100 and negative square root of 100 equaling x minus 4. If I try to simplify those, we'll have the square root of 100 is 10, and negative square root of 100, we don't want to work with negative lengths, so we'll eliminate that one for this real life situation. So 10 equals x minus 4, and last thing to do, add 4 to both sides. And so 14 inches is what my original cardboard sheet should be. It should be 14 inches by 14 inches. That way I cut out my 2-inch squares and I get a box of the appropriate volume.